Okay, hello everyone. So, here is a short discussion on Java interfaces. One of the more interesting and powerful constructs in the Java programming language. Simply stated, an interface is a collection of abstract methods. And we're going to talk about that. So let's just dive right in. Here is our agenda. So we'll talk about interfaces. What are they? We'll talk about the structure of an interface. We're going to talk about implementing an interface. Implements is actually a key word in the Java programming language. We'll have an example, a code example, and we'll wrap it up with a quick summary. We'll try to keep the whole discussion pretty quick, keep it moving along at a good pace. So here we go. An interface. What is an interface? An interface is a collection of method signatures. The signatures only. No implementation whatsoever. And a method signature with no implementation is called an abstract method. You can also put constants in an interface, but really the real power of the interface is this collection of method signatures, that is, abstract methods. So as we see here, an abstract method, it's a method header without a method body. And we'll show you an example of that in just a moment. An abstract method can be declared using the keyword abstract, and in some cases it is, but in an interface, since all the methods are abstract by definition, as a matter of fact, if you try to put any implementation into a method signature in an interface, the compiler will throw an error. It won't let you proceed. So because all the methods in an interface are abstract, the keyword abstract is usually left off. It's assumed. It's not an error if you put it in, but most people don't put it in, don't use it. So an interface is, what is the purpose? An interface is used to establish a contract. When a class indicates that it implements an interface, it's guaranteeing that it has implementations of all the methods defined in the interface. Now, a reasonable question is, what is the difference between an interface and an abstract class? An abstract class is a class you cannot instantiate, and it's designed from the ground up to participate in an inheritance, in a subclassing relationship where the abstract class is the parent and subclasses, child classes, extend the parent. And you can have some implementation in the abstract class. In an interface, you cannot have any implementation whatsoever. Zero implementation, method signatures only. And the method signatures define the interface, if you will, that is implemented by the class. So it's realized as a set of methods that an object will implement. There's a useful tutorial here in the Java tutorial. It's hyperlinked there. Here it is. And it's pretty good, like, in my opinion, like most of the stuff in the Java tutorial. So if you need additional information, go ahead and check this out. It's well done with discussions and code examples. Okay, let's continue. So the structure of an interface. Interfaces are pretty simple. The structure, you see it right here, and in many cases, there's not much to it. Here's one. Here is an interface with two methods, and let's just take a look from top to bottom. So interface itself, interface, is a reserved word in the Java programming language. So it's a keyword. So public, so we declare it usually in its own file, and this particular interface would be in a file called doable.java. So here we have public interface doable, and the opening and closing scope, opening curly brace, a closing curly brace. Within the curly braces, we have our interface, if you will, our abstract methods, our methods signature only, no implementation. So what have we got? We've got two here. Public void do this, public abstract int do that. Note that none of the methods are given a definition. They're abstract, and as I mentioned earlier, if you try to give this some implementation inside of an interface, it will not compile. The compiler will throw an error. Now note here, there's a semicolon after the method signatures. That is required. And as I mentioned earlier, by definition, all of these methods are abstract. You could put abstract in here, but you usually, quite frankly, do not see it. It's assumed to be abstract, so this abstract modifier is usually left off. Truth be told, I don't think I've ever seen it. I don't think I've ever seen anybody put it in. You can't, it's not an error, and it is abstract. It's just usually left off. Okay, so let's. So that's really what an interface is, and some of the properties, what it looks like. Here's some general information. So, an interface cannot be instantiated. We don't, we don't create, new instances of interfaces. What we do is we create instances of classes that implement the interface. And there are special cases, and I'm going to show you a special case in just a couple minutes here, where you can use an interface as a type, like a type. Methods in an interface have public visibility by default. I like to put the public in, just a habit I've gotten into over the years, but there is public visibility by default. And how do we go ahead then and implement an interface? So we don't create instances of interfaces. We create instances of classes that implement an interface. And how do we do that? A class indicates that it implements an interface by using the implements reserved word. So implements is also a reserved word in the language. So public class can't. So here we have public class can do implements doable. What does that mean? Public class can do implements doable. This class named can do, by stating that it implements the doable interface, is guaranteeing that it implements all the methods in the interface. So if you try to state that you implement an interface and don't have the method signature for each of the methods in the interface, again, the compiler will fuss at you and you'll get an error. Let's take a look at what that looks like. So it's pretty simple. So here's our class, can do. Public class can do implements doable. Implements is a reserved word. And here you see each method listed in the doable interface is given a definition. And remember, we just had two. We have public void do this, public int do that, and our implementation is in here. The implementation, that's for us to fill in. That's kind of the point. of an interface, of an abstract method. The point is, we're not specifying the implementation. The implementation is left up to the application, left up to whatever your domain-specific application is. And you'll see real concrete uses of this when we start to talk about user interface programming. There's many other reasons for having interfaces, but that's a real obvious one, and it's one one we'll actually do, and one we'll actually write code using interfaces. So here, this simple little construct here is pretty important. We say that we implement the interface. In this case, the class is called CanDo. The interface is named Doable. When we say we implement the interface, we're guaranteeing that we have those method signatures specified in the interface and implementations for those signatures. Now, important to remember, in addition to the methods specified in the interface, we can have other, quote-unquote normal members and methods in here. We're not guaranteed. We're not held to only have the things in the interface. We can have our other class information as well. So simple, but pretty important. A quick word, and again, just a quick word here. The Java programming language does not implement multiple inheritance, and there's quite a debate about that. Should programming languages have multiple inheritance or not? Java does not, and it's not going to. But what it does allow, a class can implement multiple interfaces. And when a class implements multiple interfaces, you can just have a comma-separated list. Here we have public class many things implements interface 1, interface 2, and you can have more there. Same rules apply. If you say you implement an interface or multiple interfaces, you are obliged to provide implementations of all the methods in every interface that you list here. For an interesting read, and I won't go into this right now, but it's hyperlinked here. For an interesting read, there's something called, and I'm not making this up, there's something called the deadly diamond of death. It's a situation that can occur when there is multiple inheritance in play. I recommend you go ahead and check it out. It's a pretty interesting read, pretty straightforward. I think you'll understand it pretty quickly, but it's useful to know. Bottom line here, what's important in Java? We can have a class that implements more than one interface. As a quick preview of coming attractions, because right now I appreciate, some of you might be scratching your head, and that's completely fair, saying, what? Okay, I get it. I see the nuts and bolts. I see how it works, but what is it for? You'll see the Java class library contains many helpful interfaces, and you'll see in the documentation and interfaces indicated in italics. We will specifically look at some of the event-related interfaces. So you see the list there: action listener, item listener, window listener, mouse listener. An action listener, for example, is something that we use with a push button. A graphical user interface push button is tied to an action listener. There's other kinds of listeners there as well. So as a real concrete example of where interfaces are used, it becomes pretty obvious when we start to do GUI programming. Actually, you can't really do GUI programming and meaningful GUI programming without using interfaces. So before we wrap it up, I do have a short code example here. So let's take a look here. So let's look let me see, I'll make the code just a little bit bigger here. Okay, so here is a very simple interface, public interface, shape interface, and it's got one method, and it's actually quite common. You'll see in some of the interfaces that we're going to use, it's quite common to have an interface with just one method. So here we have public double get area. What are the rules of the road? The rules of the road say any class that implements the shape interface is required to have an implementation of this get area method. So let's look. Here's our old friend circle. So the circle class implements the shape interface. Public class circle implements shape interface. What does that mean? It means I'm guaranteeing that I have an implementation of the get area method. Now notice our get area method is going to be the get area method for circles. So math, pi r squared essentially. So here's our constructor, here's our radius, here's our get area method. Let's look at rectangle. Rectangle also implements the shape interface. However, for rectangle, and the shape interface means that we have an implementation of the get area method, but for rectangle, pi r squared wouldn't make much sense, right? So our implementation of get area returns length times width. And I think you sort of see, you're starting to get the flick here. Here we have triangle. Triangle implements shape interface, public double get area, returns 1/2 base times height. So all three implement the shape interface, but they provide the methods that make sense for that particular shape, and that's really the punchline. That's the real power of interfaces. So let's try to put it all together. So here we have a driver class. Let me see if I can get it all, get most of it. There's most of it. Just expand here. Okay, so what have we got going here? Public class interface driver, there's our main. So here we have an array of shape interface. So it's an array called shape interface equals new shape interface, and it's size 3. We've got a little index in there. Now notice what we're, and this is, I mentioned this earlier, we can use an interface as a type. We cannot do this. We can't just, go ahead and try to create an instance of shape interface. So what can we do? So shape interface, S equals new, not shape interface, but new circle. Why can we do that? Because circle implements shape interface. That's why we can do that. So we're going to create a circle object. We're going to store it in the shape array. And then we're going to do the same thing. We're going to go ahead and create a rectangle object, put it in the shape array. Then we'll go ahead and create a triangle object, put it in the shape array. And when we go to run it, here, the for each form of the for loop, for each shape interface object in the shape array, the area of the shape is shape.getArea. And just for fun, this is a sort of an advanced topic, and you don't need to, it's really sort of beyond the scope of this intermediate course. But here we're using something called reflection, and we're actually going to ask the object what class are you, what class are you an instance of? So there's actually a get class method, and there's actually a get name method. So let's turn the crank and see how this works. So here, there's everything in there. I'll just for fun go ahead and compile it all again. And there it is. And let's go ahead and run it. Interface driver. And so there you go. So we've got our circle, or if you remember, the radius was 1, so pi r squared. And here, the type of this object is circle. That's this right here. The type of this object is shape.getClass.getName. And the same thing happens. Here's our rectangle. Here's our triangle. So just to wrap it up, so a Java interface, it's a collection of abstract methods and constants, but really, you know, the power, it's the methods. How do we use an interface? We implement an interface. When we say we implement an interface, we're guaranteeing implementations of all the methods in that interface. So a preview of coming attractions, a real concrete use for graphical user, for GUI widget event handling. If you don't know what that means, don't worry, you will. For event handling of graphical user interfaces, Java interfaces are widely used, and they're used in multiple. They're used in Java Swing. They're used in Android. They're used in many GUI implementations, and we will use them. So hope that was useful. Check out the code, play with it, check out the tutorial. It's hyperlinked in the slides. Okay, have a great day.